Hi guys, since we're starting our binary exploitation module, I thought I would record this video to try and uh, demonstrate some of the most common issues that I've seen with writing shellcode in the past. So the idea behind shellcode is if we can somehow get the code in a program to return to code that we sent in somehow, then we can have it execute any code we want, basically. And so if you ask Sensei to give you some shellcode, it's possible that they might tell you to create this shellcode that will read or that will run /bin/sh. What this does is it creates a shell, and inside of this shell, we can run other commands like echo or like cat flag. Although we can't actually cat the flag right now because we're not the root user. But the idea is if we're running this inside of a program that is running as the root user, then we should also be able to read the flag from here. But this doesn't actually work because the way this /bin/sh and a lot of the other shells are set up, they actually drop the permissions when you try to run it. So if you see here, I've actually given myself in this shell program, I've given it root as the owner and it has a set user ID bit. So if we run this, we would expect to be able to read the flag. But when I run this and I read the flag, it actually still tells us that the permission's been denied. And the reason for this is a little complicated. Here's a message from one of the professors about what's going on. Basically, what's happening is the shell notices that you're not actually who you're running as, and it sets you to the your real user ID. And so you're no longer root when the shell is running. If you want to read more about this, I'll put the link to this message inside of the description for this video. Yeah, so basically this doesn't work. On the other hand, if we have something that actually reads the flag directly and then prints it out for us, then it actually will work correctly. And there's an example of working shellcode in the lecture videos for this module. Okay, so that's the first issue that I've commonly seen. The second issue is in the last two challenges of this module. Uh, so in the last two challenges, we have this hijack to shellcode, and we basically the only thing you get to control is overflowing the buffer. So you have to somehow make the buffer return to your shellcode or make the function return to your shellcode. And so we somehow have to replace the return address with the address of the shellcode. And I'll try and walk through what this program does. Actually, we don't need this part, but so we have this main method and it will call this vulnerable function. And when we call this vulnerable function, it asks us to enter the shellcode into this buffer here. And then it asks you to enter the return address. Obviously, you shouldn't really do this, but what this is doing is it's overriding the return address with whatever value you give it. Yeah, so that's what's going on here. And I also have this Python script which tries to run this assembly and returns to that address. So we have the sending the return address. I should have set that to 0. So suppose we didn't know what the return address was. Then first of all, how can we figure out what the return address is? If we run it with GDB, uh, GDB ref to shellcode, and we try to figure out where it is that the shellcode is actually located. So if we look at the vulnerable function, when we call read, it's actually reading into uh, RSI, and RSI has this value of RBP minus 0x100. So if we break at read, and then we go to that place and check what this RVP minus 0x100 is, then we should be able to know what the value of the or the location of the shellcode buffer is. or if we run, and then we print our BP minus 0x100, we get that the shellcode buffer should be at this place. So maybe this is the correct return address then. And if we send this as the return address, and so in this PwnTools program, we're having it send in our payload, which is all this assembly, and we send the return address. And if we try to run this, we'll actually see it actually doesn't work. It turns out that it actually just crashes. We have this segmentation fault. It didn't run our shellcode. And just to show what our shellcode does, what it does is it prints out pom.college practice. That's all it does. It doesn't actually like read the flag. But like we don't see that getting printed out. So that means that our shellcode didn't work here. So why is that? Well, it turns out the stack, the location of this buffer on the stack actually depends on the environment variables. And when we're running in GDB, GDB actually adds its own environment variables into the program, and that actually shifts around the stack a little bit. So instead, we have to do something a little bit different. So, which is why I have this pwn.pause. So what this does when I run the program again, it waits on your input. And now that we know that this is the process ID of the program, what we can do is now we can go into GDB and we sudo GDB -p and then this process ID. And what this does is we will attach GDB to this process, which means that it won't actually, or GDB won't add in its own environment variables anymore. And now if we take a look, uh, it's right now it's at read, so we actually have to stop or backtrace. If we break here in vulnerable and we continue and we enter here, so now if we check what the return address was, if you remember, it was supposed to be RBP minus 0x100. We get that this is the return address that we should be going to. And if we try this return address, we'll actually get okay, so if we try this return address instead, this should work. So now let's take another look. And yeah, so now it printed out the pwn.college practice. Okay, so this was in practice mode because we can only use practice mode, or we can only use sudo GDB in practice mode. Otherwise, we can't attach to programs. So what if we wanted to run this in regular mode instead? So we start regular mode. Okay, so it seems like it should all work the same, right? We should still be able to get that home.college practice to get printed out since we're still uh we're we're running the exact same code, right? So if we go to the same place again and we run a program, this time it actually crashes again. We get an illegal instruction. So what happened here? Okay, so as it turns out, the environment variables between regular mode and practice mode are also different because regular mode has this as its host name, this binary exploitation basic shellcode, and practice mode has this extra word practice in front of it. So then how can we account for this? Okay, so the way we can account for this is in PwnTools, when we start up a process, we can also control the environment variables. So if we want to make the environment for both running in regular mode and practice mode the same, what we can do is we can wipe out all of the environment variables, and then we won't have this host name or anything else that's messing up the two practice mode and regular mode stack locations. And the way we do this is we have env equals brackets. Oops, where'd it go? Okay, so and then we have to go back to practice mode again because we have to figure out the real address. Okay, so we'll do the same procedure as before. So we are attaching GDB to this process and then um, breaking at the place where we just read and then checking the location, the buffer. And that was RBP minus 0x100. Okay, so now that we notice that it's a little bit different now. And we can also double check, make sure we actually got the correct return address. Where if we run here, we should expect to get the practice flag. And we did. So it looks like this return address was correct for practice mode. And we can see, does this also work for regular mode by testing it out here? Okay, so now if we run this, we expect we should be able to get the flag because we wiped out the environment variables so that both regular and practice have the same empty environment variables. So now if you run it, you get the same phone.college practice printed out. So that means that our code did work both times. So yeah, just to recap, the two things that I went over in this video are, first of all, we can't really have shellcode that opens up the shell like this without some extra modifications, which you can read about in the Discord message that I'll link in the description. And second of all, when you're trying to figure out the stack address that we want to return to, we actually have to do some extra stuff like clearing out the environment variables and attaching GDB, because otherwise the environment variables that we have in our program will make the stack shift around a little bit, and it will cause the program to like not exactly be the same values for the return address in practice mode and regular mode. Yeah, so I hope this video helped, and good luck with this module.